Hi guys, this is a Calc video 5-5 to be watched Monday, January 9th. There's going to be no homework corresponding to it. And this is my second attempt at this video, so hopefully I don't mess up at the end of this one. But when you're dealing with a definite integral, there are rules that you could use to manipulate the integral and to rewrite it. So we're going to focus on the first 5 rules today. Okay, and I'm not even sure if we'll ever do 6 or 7 in this year, but we're going to focus on these 5. So there's a rule called the order of integration rule, which says that the integral from b to a of f of x is equal to the negative of the integral from a to b of f of x. So if you want to switch, these are called the limits of integration, and if you want to switch them, all you do is negate the integral. You change the sign out front and you could switch the limits. There's the zero rule, which says that the integral from a to a of f of x equals 0. And guys, I just want to do like a little picture here. If you do, okay, let's do like a let's do a curve, and we'll say that that's f of x. And let's say that this is a. And if you do the integral, the area under the curve from a to a, you're going to get 0 because this interval has no length here, okay? Like if you put like a b over here, if you imagine putting a b over here, and then you'd actually have some shaded area to, find the area of, that would be a different situation, but this is a 0 length interval, so the area underneath the curve on this interval is 0. There's the constant multiple rule. This is a nice one. It says that the integral from a to b of k times f of x is equal to k times, sorry, my sister's sleeping in the other room, k times the integral from a to b of f of x. So you can pull a constant multiple out front. You can pull a negative out front. The sum and difference rules, if you're taking the definite integral of a sum or difference, you could split up the integrals. Additivity, this is a nice one, says that the integral from a to b of f of x plus the integral from b to c of f of x equals the integral from a to c of f of x. And this one you want to look out for, it's additivity, so you need a plus sign. That looks like a plus minus now, but you need a plus sign there. And the upper limit of integration of one integral needs to be the same as the lower integration limit of the other integral. And now let me just show you off to here what this means. Remember, these upper and lower limits represent the interval that you're integrating over. And this is the interval that you're integrating over. If this interval leaves off where this interval starts, then you could just add these intervals to get that one there. So let's do a picture off to the side. Okay, all right, and we'll say, I'll do something like that again. This is f of x, and let's say that this is a, let's say that's b, let's say that's c, all right? And so what this is saying is that if I do the area under the curve on this interval, that would be that integral, plus the area under the curve on that interval, that is the same as if I just did the area under the curve on that whole interval. All right, so that's what additivity says. That's like a visual representation. Okay, so now down here, express as a single definite integral. So what we're basically going to be looking for here is we're going to be looking to use the order of integration and additivity. So we're going to be looking for 1 and 5. First I look to see if I can use additivity. Yes, I have a plus sign. You don't have to box that up, but I'm just highlighting the important things to use additivity. Yes, I have a plus sign. And the upper limit here is equal to the lower limit there. Even if these were switched, If the upper limit of one was equal to the lower limit of the other, then you could combine them to make one integral. So yeah, I can combine them. So the interval 0 to 7 plus the interval 7 to 10 is the same as the interval 0 to 10. All right, and I could use additivity. Also, it's important that you have the same function that you're taking the integral of in both of them. Okay, now this one here, not a plus sign. Okay, so I can't use additivity, but I can use the order of integration fact or rule to make this a plus sign, and then I'll see if I have additivity with the upper limit and lower limits matching. So I'll go 0 to 7 h of x dx, and if I want to change this, or if I want to change the order of integration, or if I want to make this a plus sign, I would just change the order of integration, because order of integration says that if you negate an integral, then you can change the order of the order of the limits. So I'll go plus integral from 7 to 4 h of x dx. Okay, so now I have that plus sign that I need, and this upper limit is equal to that lower limit. So I can go from 0 to 4 h of x dx. Alrighty, and guys, some of you might be noticing that 4 to 7, that's like a backward, or sorry, 7 to 4, that's an interval that's going backwards. So, yeah, so this is not, like, it makes sense that, oh, we have a plus sign and those limits are matching, so, yeah, we could use additivity, but it might not make sense to, like, the interval from 0 to 7 plus the interval from 7 to 4, that's a backwards interval, so that's kind of weird. So let me just show you like a more visual way of thinking about this. But by all means, use additivity in the future. So this is a similar situation. We have a minus sign. We don't have the upper and lower limits of integration matching going across. And I observe that if I just were to change, if I were just to change the sign there and switch those upper and lower limits, then I would have them matching across. But I'm not going to do the same thing again. I'm going to go up here and draw a picture. So let's assume that h of x is just some continuous function like that. H of x. All right. And I want to look at these intervals underneath h of x. I want to look at 0 to 7. So 0 to 7. And I want to look at 5 to 7. Okay. So the first, so 0 to 7. 0 to 7 is this area. All right. And if I subtract the area under the curve from 0 to 7, or not, that's not what I'm subtracting. So if I take the area under the curve from 0 to 7, and I subtract the area under the curve from 5 to 7, what I am left with is the area under the curve from 0 to 5. So that's another way of looking at it, guys. So we'd end up with that green area right there. Okay. So you can do this. So we could have done this also without additivity. If you take the interval, and you could just think of it as intervals. You don't even have to draw this like I did. You just ask so you notice that you have the same function on the inside. And then you say to yourself, 0 to 7, that interval, minus 4 to 7, that interval, I would end up with the interval 0 to 4. Okay, so, and you could even do it like this. Like I had last year's people go like this. They would go 0 to 7, and then they'd put a 4 there. Okay, and then they would just think it through, like they've got 0 to 7, they're taking away 0 to 4, or is it 4 to 7? They'd end up with 0 to 4. All right, so anyway, we are going to skip the 4th and 5th examples. All right, so you can cross them off. And we're going to go right to here, and I'll start going faster. Okay, example number 6. Suppose that f and g are continuous functions. We'll talk tomorrow about why that's important. But there's no holes, there's no gaps. It's a completely smooth curve. And suppose that the integral from 1 to 2 of f of x equals negative 4, and the integral from 1 to 5 of f of x equals 6, and the interval from 1 to 5 of g of x equals 8. Use the rules in the table that was at the front to find each integral. Okay, so what I want you to do, guys, okay, I'm going to do this fast. Faster than I was imagining. All right. Okay, so let's write ourselves a note. Unless using the zero property, rewrite the integrals as sums, differences, and constant multiples of those ones there. All right, so you don't want to skip any steps. We want to use the properties and be very explicit about how we're using them. Okay, so I'm going to go kind of fast here, guys. Now this A, the integral from 2 to 2 of g of x dx, this is a 0 length interval, so this is the 0 property, that's 0. Okay, part B, the integral from 5 to 1. We don't know the integral from 5 to 1. So now, and this obviously isn't the 0 property, so what I said over here, unless using the 0 property, rewrite it as a sum, difference, or constant multiple of one of the others. Well, if I were to just switch these limits of integration, I could do that by negating this. So 1 to 5 g of x dx. And I have a constant multiple, a multiple of negative 1 of this one here. All right, so this is actually negative 8. All right, now for part C, integral from 1 to 2 of 3f of x. This one is not up here, but the integral from 1 to 2 of f of x is. So I want to rewrite this one as, you know, explicitly as this one. So I'm going to just take out a 3 using the constant multiple rule. So I would end up with 3 times this known integral, which is negative 4. So I'm running out of room. This is, so 3 times negative 4 is negative 12. All right, so this one was negative 8. That one was 0. This one is negative 12. Okay, now 2 to 5. Guys, this one is going to take some thinking, so I will come back to that. All right, so we're going to come back to D. Now the integral from 1 to 5 of f of x minus g of x. Well, we can use the rule that says we can split up an integral over addition or subtraction. So this is the integral from 1 to 5 of f of x minus the integral from 1 to 5 of g of x. Okay, this integral we know, it's negative 4 minus this integral we also know it's 8. So that one is also negative 12. All right, this one here. So I see a difference of two, I see a difference of two functions that I'm taking the integral of. And then in front of this function, I see a constant multiple. So I'm first going to use the rule that allows me to split these up, and then I'll pull out that constant multiple, but only in front of this, of the integral of this one. If these both had a 4, then you could factor out the 4 and then pull it out front, but these both don't have a 4, so I can't just pull the 4 out front without splitting them up first. So we've got 1 to 5 for f of x dx minus 1 to 5 g of x dx. Then I can pull this 4 out front. 1 to 5 f of x dx minus 1 to 5 g of x dx. All right, now I'm just carrying down that 4. This integral, I'm looking above, and I see that it is 6 minus this integral, I'm looking above, and I see that it's 8. So we get 24 minus 8. Is that 6? I think that's 16. Comment under if that's not 16. But I'm pretty sure it is. Okay, now back to this one. 2 to 5. I'm, you know, I'm looking at this and I'm stuck. I can't just like, you know, there's no constant multiple here that I could pull out. So this interval 2 to 5 does not show up here. So I have to ask myself, can I express the interval 2 to 5 as a sum or difference of the intervals 1 to 2 or 1 to 5? I don't have to even worry about this integral because we're only working with the function f of x here. So I'm going to draw a picture over here. Now they said that these were continuous functions. They said, okay, let me draw a picture of these two, okay, and then see if I can work backwards or work from there. Okay, so I'm off to the side. All right, this is just, you don't have to do this in the future, but let's just visualize this. I know from 1 to 2 that the area under f of x is -4. So a negative area would mean that the function has to be below the x-axis, or at least most of it is below the x-axis. So let's just assume that it looks, I don't know, something like that. Okay, I'll color that. All right, so that area is, let's say, -4. And then we know that from 1 to 5, so I'll say that 5 is like out here. We know that the area from 1 to 5 is 6, okay? So when I add this area to the area that I've already got, -4, together they would have to make +6. So I'll make this pretty high to compensate for that negative part. Okay, and what I do know is that total area equals 6, okay? Oh yeah, so, and they want the area under the curve from 2 to 5. Well, I know that if I put both of these sections of area together, I will get +6. And I know that this part is -4. So I would have this shaded area, the positive shaded area, if I just cut off this negative shaded area, if I just consider the area from 2 to 5. So basically I'm subtracting this negative part. So this is going to be the integral from 1 to 5 of f of x minus the integral from 1 to 2 of f of x. All right. And then from 1 to 5, I know I've got 6. And then minus from 1 to 2, that's -4. So that should be -10. All right. And if this was a little bit confusing, guys, my picture, then you could think of it this way too. Just think of the intervals Okay, you don't have to write this down, but you could just think of the intervals. That's what I would have them do last year. I've got the interval 1 to 2, and I've got the interval 1 to 5. Okay, I know the integrals on these intervals, and I want the integral on this interval. Well, what do you do with this big interval and this little interval to get that one? You would just subtract them. So this is something from geometry. You might remember whole minus part equals part. So this whole interval minus this part of it would give you that remaining part. So that's how I thought that through. That's actually not one of the properties. Alrighty guys, kind of a long video, but actually it's a good thing I messed up the first time because this ended up being shorter than the first one. Alrighty, I will see you soon. Bye-bye.